Hi everyone, it's my honor to speak here, and today I'm going to introduce our Chinese grammatical error correction based on hybrid models with data augmentation. The speech will follow these 4 steps: introduction, methodology, experience, and the final conclusion and future works. At the very beginning, I'd like to introduce where we come from, Xinhua News Agency. Xinhua News Agency is a state institution with headquarters in Beijing, and it collects and posts domestic and international news on politics, economics, cultural, and other areas. And we all believed in the news media industry, grammatical error correction is significant. And this is also one of the reasons we joined this competition. Also, the data we extract from the database of Xinhua News Agency plays a vital role in our model. Here is our final result. As we can see, we got the 4th place on the crash level type 1 and the correction level type 3, and the 7th place in the detection level, and 8th place in identification level and position level, which is not bad. Of the models, data is the base. So for the data preparation part, we use the HSK dataset, which is provided, and we find the Line 8 dataset from the website. Also, we use the dataset of Xinhua News Agency articles from 2017 to 2018, and also dataset of essay comes from the Harbin Institute of Technology. These 2 datasets to do the data augmentation part. For the data augmentation, this is a brief introduce about the 4 error types: missing word, redundant word, word selection, and word order. And we use 2 methods to generate the corporate data from these 4 types. And the first method we use is rule-based corporation. And here is the procedure code for our algorithms. We borrowing the once method, but make a little bit of changes. Our method performs both word grain and character grain corporation, and introduce a sentence grain word ordering error to corpora. And here's the result. The second method we use is neural network-based corporation. We train an attention-based sequence-to-sequence model with a biodirectory GRU encoder to generate noisy counterparts for clean sentences. We define a new noisy score to improve our performance. Here is the model and the result. Then it comes to our methodology. Here is our diagram of GEC system, which we gather raw data and the augmented data as input, go through the spell check models, generative models, and recursively repeat these 2 steps until we got all of the results, and use the rank method to get the best. And next, I'm gonna talk about details about all of these 3 steps. First one is spell check models. We use 2 spell check models. The first one is spell GCN. It's a graph convolution network. It uses a confusion vocabulary to generate the graph network and get output combined with the BERT, and then get the result. And the second one is Electro. It's a pre-trained language model for Chinese vocabulary. The reason we use both 2 models because they could be supplementary to each other, and we think we could get better performance based on these 2 models. And we come to the generative models. The first one we use is convolution sequence-to-sequence with decoder and encoder. And the second one is called laser tagger model. Since in this competition our original sentences are similar with the output, therefore this model uses a transfer model to keep the original words and give all of the words a tag. Therefore, we think this method is suitable for our task, and also we could get better performance. Then we comes to the embed Reranker. As I said before, here is a pipeline of our model. We will do spell check models with 2 models parallelized, and the generative models 2 models parallelized, and recursively multiple times. Finally, we will get multiple outputs. Therefore, we need a way to order them and get our embed. Therefore, we propose 2 methods. The first one is simple re-rank. Just simply use the output of the bird and calculate the result. And next one is merge. It combines added operations, n-gram perplexity, bird score, and length penalty to generate the final result and get the order of the sentences and get the embed. Finally, after we implement these 8 models and do the experiment, we get our result. Here is the table. As we can see, we use the laser tiger model with augmented data and spell check model. We can get a better performance on the correction top 1. And also, the merge re-rank method could get the best performance on detection and identification. Therefore, we come to the conclusion in future works. As we see on the table, the previous slides, the augmented data with spell check has a high score on correction top 1 section, and the merge re-rank method has the best performance on both detection and identification parts. And for the future work, we think maybe we could improve our data augmentation methods, and also we can find a better re-ranking strategy to get a better performance. Also, for the evaluation part, we think the tokenizing of the Chinese and the English is quite different. And also, the result we got from the sequence-to-sequence model are also different. So the way we evaluate, maybe we could get a same format way to evaluate our result, maybe better. So, thank you for your time.